review adding, subtracting, and multiplying polynomials. When we are adding polynomials, let's review what the word polynomial means. Polynomial just means an expression with multiple terms. You can have a trinomial, such as this one, where you have 1, 2, 3 terms. You can have a binomial, like the second one, which has 2 terms. You can have a monomial, or it's just called a polynomial. So in this case, we are adding 2 polynomials together. We are adding a trinomial plus a binomial. And because it's an addition problem, we are simply combining like terms. So I'm going to find all of my terms that have an x cubed, and I'm looking down the line to see if I have anything else to combine it with, which I don't. So I'm just going to bring down 3x cubed as part of my answer. Next, I'm going to look for any terms that have an x squared. They have to have the same variable with the same exponent. So I have a positive 4x squared. I'm looking down the line, and I'm going to combine that with my like term, 2x squared, so that I get a total of 6x squared. And finally, I'm going to look for my constants, which I have a 1. Look down the line, and I only have a 10 left. 1 plus 10 gives me an 11. These are 3 terms with different variables and exponents. So I am done with this problem because I cannot simplify that anymore. As I move over to number 2, I have a subtraction sign. So this time I'm taking a trinomial and I am subtracting the binomial. But the one thing you have to remember is that you're subtracting everything inside the binomial from the trinomial. So you are subtracting the 4x and you're subtracting the 2. So sometimes it's easiest to just go ahead and distribute the subtraction sign so that you don't forget that you are in a subtraction problem. So I'm going to rewrite the second binomial here with the subtraction distributed. So I have negative 4x, and I'm going to distribute the negative to the 2 as well, bringing down my trinomial. Now I can look for my like terms. So first I'm going to look for anything that has an x squared, which I don't have anything else, so I'm going to bring that down as my part of my final answer. Next I'm going to look for any x terms, which I have a negative 4x, so I have 3x minus 4x, or 3x plus a negative 4x gives me a negative 1x, or just a negative x. And then finally I have my constants, which gives me a negative 3. Now I have my final answer in simplest form. So the key with subtraction is to make sure to distribute the subtraction sign to your second polynomial. Finally, we're going to look at some multiplication. Multiplication is simply using the distributive property. So for this first example, we are distributing this monomial to each term in the trinomial. When you're multiplying, we have to multiply the coefficients, and using our laws of exponents, we have to add the exponents. So this is a 2x, which means there's an exponent of a 1. So I'm going to distribute and multiply 2x times 4x squared. So 2 times 4 is 8, and I have 1x that goes with the 2, and I have 2x's with the 4, so that means that's x to the third power. So 8x to the third power. Now I'm going to distribute the 2x to the 5x. 2 times 5 is 10. X plus x is x squared. 2x times 10 gives me a 20, and the x has to come along. Again, no like terms to add together, so this expression is complete. Our final example is a binomial times a binomial. We are still using the distributive property. I'm going to show you 2 different ways that you could solve this. And one is simply using the distributive property, which means I'm going to take the x from the first term, and I'm going to distribute it to everything in the second polynomial. So x times x becomes x squared. X times 10 becomes 10x. Now I also have to distribute the second term in the binomial to everything in the second polynomial. So I'm going to do 1 times x gives me a 1x. 1 times 10 gives me a 10. Notice how I drew my arrows for the first term above the expression and the arrows for my second term below the expression. That way I don't get confused, just as I am making sure I use the distributive property properly to both terms. So now that I have my multiplication done, I have to look for like terms, and I have two like terms sitting right in the middle. So I end up with a x squared plus 11x plus 10. This is my final expression after multiplying the binomial times the binomial. Now, some people are a little bit more visual and would prefer to see this in a different format. So because it's a binomial times a binomial, the other way we could do this is using what's called the box method. So I'm going to draw a box, and since it was a 2-term times 2-term polynomial, I'm going to create a 2-by-2 box. On one side of the box, I'm going to write the first polynomial, and above the box, I'm going to write the second polynomial. Now I'm going to take the terms on each side and fill in the squares. So x times x gave me x squared. X times 10 gave me 10x. 1 times x gives me a 1x. And 1 times 10 gives me 10. One thing that you should notice is that the diagonals are like terms. So I'm going to add my like terms that are diagonal, and I get x squared plus 11x plus 10, which is the same solution that I did when using just the distributive property. So when multiplying polynomials, you are using the distributive property. You can either write it out using arrows and distributive property, or you can use the box method.